Good evening, sir. I am Sai Balaji from ECB section and my roll number is 234G1A0498. Today, my topic is about numerical problem on lag lead compensator in control systems and the subject code is 23 404. Numerical problem on lag lead compensator. Example problem. Design a Lagrange compensator for a system with an open loop transfer function g of s equal to k by s into s plus 0.5 to satisfy the following specifications. Damping ratio of dominant closed loop poles zeta equal to 0.5. Undamped natural frequency of dominant closed loop poles omega n equal to 5 radians per second. Velocity error constant kb equal to 80 second inverse. Problem solution. Step 1. Determining dominant pole SD. We know the formula for SD equal to minus zeta omega n plus or minus j omega n into root of 1 minus zeta square. Here omega n is given in the question already. It is the value 5 equal to minus 0.5 into 5 plus or minus j5 into root of 1 minus 0.5 square. We get solution as minus 2.5 plus or minus j into 4.3. It means on real part it is minus 2.5. On imaginary part it is 4.3. Step 2. Draw the pole and zero plot on the graph paper. We know that poles are denoted as x and zeros are denoted as 0. Dominant poles are denoted as p. Step 3. To find the angle contributed by lead network. Phi equal to sum of angles contributed by poles of uncompensated system minus sum of angles contributed by zeros of uncompensated system plus or minus n into 180 degrees. From the denominator of the open loop transfer function, we have two poles. They are s equal to 0 and s equal to minus 0.5. And there are no zeros in this transfer function. Marking the poles s equal to 0 and s equal to minus 0.5 and dominant pole p equal to minus 2.5 plus or minus 4.3 on graph sheet. Draw a straight line from P parallel to x-axis. Draw a line from P to origin O and P to minus 5 to know the angles of those lines. Just measuring with protractor we get as 120 degrees. It means one side is 60 and another side is 60. Drawing the lines from all poles to common dominant point for knowing the values of theta 1 and theta 2. We get theta 1 and theta 2 as 120 and 115 degrees. Marking the poles here on the graph sheet 0, 1, minus 0.5. In this given question, s equal to 0 and s equal to minus 0.5. And dominant pole P equal to, we get dominant pole P equal to minus 2.5 plus or minus 4.3. It means here x has minus 2.5 and the imaginary part minus 4.3. If we intersect these poles and these dominant pole, we get here angle 120 degrees. It means here is 60 and another side is 60 degrees. Drawing parallel line with x-axis from dominant pole PA, it is known as AP. Sum of angles contributed by poles of uncompensated system is theta 1 plus theta 2. We get theta 1 as 120 degrees and theta 2 as 115 degrees. It means 120 plus 115 equal to 235 degrees. Phi equal to 235 plus or minus n into 235 degrees, where n equal to 1. Phi equal to 55 degrees. To find step 4, to find pole and zero of the lead section. Draw a line AP parallel to x-axis. The bisector PC is drawn to bisect the angle APO. Angle CPD and angle BPC are constructed as shown in figure below. Angle CPD equal to angle BPC equal to 55 by 2. We get as 27 degrees approximately. From the graph, pole of the lead section PC2 equal to minus 10. 0 of the lead section ZC2 equal to minus 2.65. We know the formula ZC2 equal to minus 1 by T2. T2 equal to minus 1 by ZC2, where ZC2 equal to minus 2.65. It means 1 by minus 2.65 equal to 0.37. We know the another formula for PC2 equal to minus 1 by alpha T2, where alpha equal to 1 by 10 into 0.37. We get alpha as 0.265. Step 5. Transfer function of lead compensator. G2 of S equal to S plus 1 by T2 by S plus 1 by alpha T2. We get, if we substitute these values in this formula, we get G2 of S equal to S plus 2.65 by S plus 10. It is the transfer function of the lead compensator. Now we have to find transfer function of lag compensator. Let me explain this graph. If we draw lines from all poles to the dominant pole, exactly, we have to measure these lengths of L1, L2, L3, L4. Step 6. To find the gain K, we know the formula for K equal to product of vector length from all poles to S equal to SD by product of vector length from all zeros to S equal to SD. In the previous slide, I have explained we have to measure the lengths of these by scale. The formula is L1 into L2 into L4 by L3. We get as 42.8. Open loop transfer function of lead compensated system is GO2 of S equal to G2 of S into G of S. S plus 2.65 by S plus 10 into K by S into S plus 0.5. GO2 of S equal to 42.8 into S plus 2.65 by S into S plus 0.5 into S plus 10. We get the length L1 as 5, L2 as 9.5 into 0.5 equal to 4.75, L3 equal to 4.3, L4 equal to 9.75. Now substitute these values in the K. K equal to L1 into L2 into L4 by L3. It is 42.8. Step 7. To find transfer function of lag section. ZC1 equal to 0.1 into second pole of G of S. We know that second pole of G of S is minus 0.5. It means 0.1 into minus 0.5 equal to minus 0.05. ZC1 equal to minus 1 by T1. T1 equal to 20. Pole of lag section. PC1 equal to, we know the formula, minus beta, minus 1 by beta T1 equal to, let's assume beta equal to 4 equal to minus 0.0125. Transfer function of lag section is G1 of S equal to S plus 1 by T1 by S plus 1 by beta T1. G1 of S equal to S plus 0.05 by S plus 0.0125. Step 8. Transfer function of compensator system is GC of S equal to G1 of S into G2 of S. GC of S equal to S plus 0.05 into S plus 2.65 by S plus 0.0125 into S plus 10. If we draw a block diagram for this equation, it is as shown below. It is G1 of S and it is G2 of S. It means it is serial. It is in serial. If we multiply those, we get the output. Open the transfer function of compensator system. G of S equal to 42.8 into S plus 0.05 into S plus 2.65 by S into S plus 0.5 into S plus 0.0125 into S plus 10. Step 9. Checking velocity error constant of compensator system. We know the formula KVC equal to limit S equal to 0 into limit S into G of S. Limit S into 42.8 by S into S plus 0.5 by S into S plus 0.5 into S plus 0.0125 into S plus 10. Which we get as 90.7. Conclusion and result. Step 10. Conclusion. KVG of compensated system satisfied the above requirement. Result. Transfer function of Lagrange compensator is GC of x is equal to s plus 0.05 into s plus 2.65 by s plus 0.0125 into s plus 10. Thank you.